Hello there, awesome peoples. Welcome back to our YouTube channel. Myself, Himang Joshi. I am a blockchain, DeFi, and AI developer from the team Token Minds. And today I embark upon this journey to explain the concept of LLM agents to you. So if you don't know what LLM agents are, stay tuned till the end of this video because after 22 minutes, you will be sound enough to explain the concept of LLM agents by yourself. So before any further ado, and before any big introduction, let's dive deep into it. So what are agents? What is the first thing that comes to your mind when you hear the word agents? So like for example, when I hear the word agent, the first thing that comes to my mind is the original Sean Connery from James Bond, and like how he was the best from everyone. But we are not really here to debate who was the best Bond, but just to explain that an agent is an entity or a person who is better or acts on the behalf of someone or another personality. So in the movie, when we hear about James Bond or when we say Man in Black, we see that those persons are intelligent and they are better than the other persons, and they are acting on the behalf of an organization to participate and to complete some task. Similarly, if we bring down that concept to the world of artificial intelligence, here the agents means an intelligent system that interact with some environment. So it can be agent in the movies like James Bond, it can be agents in, so for those of you who are trying to find a home, you must be going here and there with real estate agents. So all of these things who are making your task easier, who is interacting on the behalf of you to help you solve some certain kind of problems, are the part of agents. So basically, if we broadly divide agents into the world of computer science, there are two kinds of agents. The first one is physical agent, and the second one is a digital agent. So into the physical agents, we see the robots, we see the Tesla robots that was recently shown by Elon Musk on one of its presentation. And then on the digital agents, there are the LLM agents. So now we have a good understanding of what agents are. Let's try to understand what is an LLM agent. But we are still left with to understand one concept, and that is LLM. So let's try to understand what is LLM word by word. So the word LLM means large language models. So what is large language models? You can understand this as um, a machine learning model which was trained on a very vast amount of data set and which is used to generate human like responses. So basically what it does is that it operates by predicting the next word, and then it's gonna give out a response which a human could almost give out. So basically it's an AI kind of system that is trained on a very large amount of database to give out responses which a human could do, and that is the meaning of a large language model. And the classic example of an LLM is ChatGPT, your cloud, Perplexity. So basically, LLMs have billions or even trillions of parameters which are adjustable weights within the neural network that enables it to learn and generate complex patterns in text. So now we understand the two concepts. One was LLM, the other one was agents. So now let's combine these two things and understand the the main topic of our talk, that is LLM agents. So when we compare, so when we take out the agent and when we take the LLM, we understand an LLM agent can be a machine that has an agent that has a LLM as its central computation. The main intuition behind agent is modeled using a LLM as its central computational engine to reason through a problem, plan to solve the problem, and use a set of tools to solve it. So basically, let's say we have all been using ChatGPT for over an year now, and when we give a text to ChatGPT, if we try to summarize it, it works in a very linear manner. So basically, you have your query, it goes to an LLM, and it gives out a prompt and or an output. So basically, in this way, what happening is that it's just getting the human like text output from the query, and it's giving a very generalized output. But if you give an access to, let's say, memory, if you give an access to knowledge, if you give an access to create some patterns out of it, you can make it as your own agent. So basically, let's say we take an example in the world of LLM agents to explain a classic case of vacation. So let's say if you go into chat gpt and you ask the LLM agent that, hey, I want to take the vacation, so can you guide me to it? And it's most probably going to give you a wrong response, because that LLM agent does not really have access to a memory, and it does not know the reasons, and it does not know how to act on it. But let's take an example and introduce the concept of a system design into it and make the model more modular. So what it's going to do is that it's going to take your query, it's going to go out into the database, it's going to fetch that database and understand that, okay, you have 8 days of vacation left, so it's going to give a response according to that. So if in case you wanted a vacation for 12 or 15 days, so a normal LLM agent would have said, okay, you can take a 15 days of vacation, you gonna go to Hawaii, 15 days is good enough, or you might can also visit some islands in Bahamas or stuff like that, so that you have can use your vacation more, utilizing it more. But when you take a concept of LLM agents, it's gonna say, no, you cannot really take a 15 days holiday, you only have 8 days of vacation left. What you can do is that you can skip some other parts, you can just visit certain places in Hawaii or in Thailand, and then it can plan it accordingly. So basically what it's doing is that it's making your task more easier by getting access to your memory, by understanding a reason to act, and by creating and by using some more tools. So now let's understand how do LLM agents work. So just as I explained, LLM agent works on the two part, which is the reasoning. They process and analyze the input using LLM capabilities to predict the best next step patterns on the learned pattern. So basically it's understanding, and it's getting a reasoning, and it's getting access to your memories, it's making the knowledge, and it's acting, and then it's gonna act on those tasks. Like here, acting can also mean searching, it can also means calculating, it can also even means deploying the task onto another LLM. So it can be various things. So the main two things are reasoning and acting, and the third thing is always access to the memory. So now let's understand what are the key techniques in LLM reasoning. So the first key techniques in LLM reasoning is chain of thought. So basically, chain of thought was first introduced by Google scientists, researchers, which means by that solves problem by breaking them into logical steps. So basically, chain of thought means that when you want to solve a problem and you want a solution to understand it by step. So let's say if I want to calculate the age of an x, let's say I am 3 times older than my son, and I want to calculate, and I have given my son's age and I want to calculate my age. So let's say my son is 10-year old and I want to calculate my age. So basically here I'm just gonna give a step by step arithmetic reasoning that, okay, so now if my son is x and my age is 3x, and if my son age is 10, my age will be 3 into 10, which is going to be 30. So what I'm basically doing is that I'm giving it a step by step understanding of how I want my outputs to be. So I'm gonna feed my LLM in a way that I'm just gonna tell my LLM that, hey, whenever I'm gonna ask you the questions, you're gonna give me a chain of thoughts. So basically what I'm giving my LLM is that if I ask my LLM so a question that plan a holiday for me in US. So what it's gonna do is that, and then I'm gonna give an answer by myself that when I ask plan a holiday for me in the US, you need to ask me how many days of holidays am left with, and then how many like what is my budget and what places I want to visit, and then plan the holiday accordingly. And then I'm going to give it 2 or 3 more times so that it learns that the outputs that I'm expecting out of the LM is going to be in this case. So basically the fourth time when I really want to know about it, like I really want to understand that, okay, plan a trip for me in Mongolia, then it's going to ask me all those questions step by step, and it's going to give me the answers by breaking them into logical steps. So basically that is the concept of chain of thoughts. Now then came the another concept, which was the zero shot chain of thought. So basically the scientists from CMU, Carnegie Mellon University, and Google, they understood that if we just add the word explain step by step without even giving the prompts, if we just explain the word explain it step by step, the LLM is doing it efficiently. Like it is it is handling those tasks like it has been trained using for general knowledge. So basically, when we are just adding a simple line of explain it step by step, it's doing the work itself. And that raised the thing of self consistency. That means that LLM evaluates multiple reasoning paths to find the most consistent solution. So it's learning from multiple reasons, and it's finding a solution that is the most consistent. So here it comes out the access to the memory and access to a centralized database for your own for your own prompts or for your own knowledge. So now let's try to understand it by an analogy of solving a puzzle. So what chain of thought is gonna do is that it's gonna start organizing the puzzles logically from edges to form the picture, whereas a zero short chain of thought is gonna put the pieces just like that, and it's just gonna find the pieces that are connecting to each other. So basically what it's gonna do is that it's doing the same thing, but it's getting a more consistency. And what self consistency is going to do is that it's trying to fit several pieces into the same spot, and then it's evaluating which one fits the best to ensure looks like the final picture. So this analogy explains the difference between COT, ZCOT, and self consistency. Uh, Lastly, the concept of zero shot chain of thought was introduced in a paper published by the researchers from the University of Tokyo in a paper title called Large Language Models are Zero Shot Reasoners. So, just like I explained earlier, by simply adding the phrase "let's think step by step" before generating an answer, they have dramatically transformed how these models solve complex reasoning tasks. So, basically, they demonstrated the ability to improve the problem solving accuracy from just 17% to almost 17% on mathematical challenges without providing any additional training examples. So that was how the LLM agents improved from chain of thought to zero shot chain of thought, and then ultimately it led to a self consistency. So now let's go and understand the concept of LLM acting. So, LLM acting refers to the use of LLMs to stimulate, act as specific entities, roles, or personas based on a given prompt. So, basically, this concept enables the LLMs to expertise or behave in its responses, enhancing its ability to fulfill specialized tasks or provide tailored interactions. So, the classic examples of having an LLM acting can be education and training. So basically, as a tutor or a mock interviewer, you can have your LM agents act in certain ways, or maybe in customer support, acting as a virtual agent with specific brand knowledge. And in the hindsight, the role is doing is that it is bridging the gap between understanding and action. So the key concepts in LLM acting is grounding. So basically, the grounding means that it ensures large language based inputs have a practical outputs, and it's not deviating here and there. It's just getting us good output. And how it's doing is that it's using the concept of zero shot COT, and to ensure that the output that it's getting is not really deviating from any kind of inputs. Then it's using the tool integration, which is connecting with external tools, such as it can even connect to a sheet, an Excel, search engine, calculators, or any other future LLMs. And then the best part is retrieval augmented generation. I'll explain it later on. So right now we just skip it for a bit. But in hindsight, what retrieval augmented generation means is that it uses it uses the text to generate more accurate and context aware responses. So first try to understand this in an analogy, which means that an assistant understands the instructions to prepare for a meeting, and then it translates into practical docs and tasks, which means the grounding. So basically, an assistant is getting his or her hand onto arranging the docs, scheduling the reminders, setting up the room for the seminars and stuff like that. Then assistance is going to connect with tools, and then it's going to send out the email reminders, the calendar reminders to the relevant stakeholders of those meetings. And if you ask about an unfamiliar topic, the assistant is going to research on the spot and is going to give a more accurate response that comes in the part of the RAG. So we understood with an example of personal analogy what does it mean. So now let's try to understand that how can we unify the reasoning and acting in an iterative process. And here it enters the concept of react. Now if you notice the word react, it is combination of two words, which is reasoning and acting. And as I've been explaining earlier, that LLMs, who the LLM agents who are working, and to make LLM as an agent, you need two process, which is reasoning and acting, and that gives birth to the react. So react is nothing but a reasoning agent, and the concept of react is that it is gonna analyze, plan, and execute task in real time. It's gonna go into a feedback loop. And so for example, if you have a user query, it's gonna plan the output, it's gonna think, it's gonna act. And in the acting, it means that it's gonna use the tools to integrate, and then it's gonna observe. And once it's observing, it's gonna understand the output, that if the output that is coming is really relevant to the given input or not. And if it sees that the output is relevant to the given input, it's gonna give the answer. Otherwise, it's gonna again plan and think. So basically, it's following a loop of it's taking user query from one end, it's going to planning thinking stage, it's then going to acting. Here acting, it's going to take tools, and then from acting, it's going to observe the output. So observation is a very really important thing, because observation allows it to iterate it again to a loop, so that it gives a correct output. And if on the output, it have a set of protocols that it matches with to understand if the output is right or not. And once it gets the right output, it's gonna give out the answer. And if it's not getting the right output from the observation step, it goes back again to the planning, reasoning, or thinking step. So basically, it refines its action based on outcomes, ensuring higher accuracy and smarter decisions over time. So if you think it on a timeline, on a pipeline, so basically, the classic case of LLMs are programmatic logic. It is human fast, like it is like like a human based logic. It can think fast. That's the thing of it. But if they have less accuracy, they have like it can have good thinking, it can have fast thinking, but it is going to have less accuracy as compared to the LLM. When we make it to agentic LLMs, what it's going to do is that it's going to have a slow thinking but a very exponentially high accuracy as compared to that. And the concept of react was first introduced in a paper called React Synthesizing Reasoning and Acting in Language Models. It's a very interesting paper. I've just included the screenshot of it, and you can try and have a look at it. It's a very interesting topic, and it's a very and on the terms of publication, it's a fairly new paper, not very old. It was just published on 6th October 2022, and it explains the concept of React very broken down in a very good terms. So if you want to know more about it, you can go and search synthesizing reasoning and acting in language models. It is has been done by the researchers in the Google as well. So yep. So now why like React is transformative for Web3. So basically, it allows dynamic adaptation, it improves efficiency, and it gives broader application. So if we think in a way of dynamic adaptation, it adapts in real time, and it's gonna understand, it's gonna observe, it's gonna give outputs in the real time according to changing conditions. It has improved efficiency. So like basically, it reduces manual effort. Like for example, if I give prompt to ChatGPT, it's gonna ask for my prompts again and again until I get the right like right answers. But if I give a prompt to a domain specific LLM agents, it's gonna understand, and I don't really need to have much manual effort to get a good decision. And then it has a broader application. Like I can create my LLM agents for the good use is a truth terminal. So basically, I can create my LLM agent to promote my let's say a cryptocurrency on Twitter, on X, and I can also use it to have a better liquidity on X, on a V4 hook, and like stuff like that. So like you can have LM agents for all of your specific tasks. And the like the broader you think is a broader the application it can get. So in the end, I just want to end the seminar by saying that build smarter and adaptive Web3 application with us. If you have an idea of creating an RAG agent, and if you don't know, you can just reach out to us. We are very happy to help. And stay tuned for the next stop. Next, in the next topic, I'm gonna explain and break down the concept of RAG so that you have a better understanding of what RAG is. Thank you for tuning in, and I hope that by now you have understood the concept of LLM agents. And just go on, try to explain the concept of LLM agents to your friend, and do let me know in the comment sections if you have any difficulties in understanding it, and I'll be happy to tune in and help out there. Thank you once again. Bye bye. See you next time.